Hi, everyone. Thanks for joining my talk. I'm Dean, as Bavitra said, and I'm going to be talking about machine learning in production and specifically what production even means. So to get started, let's talk about buzzwords. Who doesn't like them? They make us sound smart. They allow us to convey a lot of information with a single or few words. But they also introduce inferential distance, which means that the things that you take for granted people have not yet learned. And they can be confusing. Now, this isn't to say that buzzwords are inherently bad, even though the term sometimes does evoke a negative sentiment. They can be dangerous, however. They give us the feeling that we understand something without always being able to really explain it in simple terms. And specifically, I want to talk about one buzzword that I took for granted, which is production. So I want to start with a story. I was giving a different talk about applying machine learning in practice and covering a bunch of things related to MLOps. And I shared the obvious notion that machine learning models are not just for research, maybe not even mostly for research. And then I asked the audience what I thought was a very simple question, which is if you create a really great model, but no one uses it, or in other words, it's not deployed to production, does it really matter? And I thought that this would be a great rhetorical question to get started with my talk. But one of the listeners raised their hand and asked, when you say production, what exactly do you mean? And I found myself noticing this inferential distance I was talking about earlier. I was treating something vague that seemed clear to me as a given and asking questions about it when in fact many data scientists or in the audience might have a different notion of what production is, or they don't really understand what I'm talking about. And that is how this talk came to be. So back to our question. Let me ask you again. If you create a great model, but no one uses it, does it really matter? Now, applying a first principles approach, let's try to define the term production in the context of machine learning models. So I would argue that putting a machine learning model in production means that your machine learning model's predictions or outputs directly affect some product or user, whether it's by educating them, helping them make decisions, or enabling them to do something that they couldn't before. For example, creating a sort of Van Gogh style Shakespearean meme for the purpose of this talk. So all of the images here that aren't icons were created by Stable Diffusion. And to add a bit more context, right, there was this famous statistic about 87% of models not making it to production. And this statistic is probably incorrect, but my interpretation of this sentence is that a large part of machine learning models never make it to the point where they actually have an effect on any products or users or consumers. And so you might ask at this point, why should you care, right? And I think that there are, for a lot of people that are new to the field, but even in the case that you are an advanced practitioner, right? Hearing the vague term production thrown around, but not really understanding what it means. So I'm going to try to fix that, right? The other thing is, we're going to see what lies behind a certain buzzword. But even if production is sort of clear to you, but you have some other buzzword, maybe feature store or active learning, and you kind of, sort of, but not really understand it. So I'm going to try to show you how to deconstruct these ideas and rebuild them from the ground up so that they might be, so this might be widely applicable and not just to production. And last but not least, I'm going to try to provide a first principles approach to thinking about model deployment, what challenges you need to solve, and showing you the first steps you need to take in solving them. Great. So now that we've defined production for models, we can ask another question. What types of production are there? And the easy answer here is to go straight to the various ways in which we can deploy a model, which is indeed a form of production. And we'll dive into it in a moment. But it's important to note that it is not the only way to deploy a model to production. And as a preparation for this talk, I asked the kind people of Reddit what production looks like for their team. And I got many interesting answers. So the easy one is that for many of them, it was actually deploying a model endpoint. And in this case, the deployment might be done as a Lambda function or some other solution. But it might also be that they're building the model into an application that runs on an edge device, whether it's your mobile phone as part of an app, or a car if you're building an autonomous vehicle. Another thing that is totally different. So for some, they run the model locally on a regular cadence, and then they upload the predictions as a table to a database, which is queried by different consumers within the organization. One specific form of this is that your sort of model is an internal means to an end. So some people shared that their production is basically a dashboard that they send out to management that uses machine learning models to create some of the information within it. That still counts, right? And then last but not least, it might be that your model is part of a larger ETL pipeline that sort of creates just a single feature. In other words, your model might be just another part of a pipeline. And I think this last point is worth diving into. So when we think about machine learning, we usually imagine a machine learning model, which is some black box with potentially weird math magic happening inside it that receives data and spits out some prediction, cat or dog, right? And while this might be how production looks like for some people, from our experience in most times, this is an oversimplification of reality. And in most cases, reality is usually more complicated. So I would argue that this is a better model for real life. So you're trying to deploy a pipeline, right? And this pipeline can include ETLs, it can include multiple models. And so the model prediction is de facto a form of data transformation, and you need to ensure that the pre and post processing steps are properly deployed to production. And so in some rare cases, your model will receive data and return a prediction, but in many others, you're going to need to add custom processing before and or after to have a real effect in the world. Now, this might seem sort of nitpicky. So why do I think that this difference between thinking of models as sort of a single black box versus a multi-stage pipeline matters? I think that first and foremost, this is sort of a change in our mental model of what production looks like. And it will affect how we think about building production grade models. We can't build in a vacuum, and we need to have an understanding of the relationships between the models that we are training and the data that flows through them. We're trying to develop a mindset that starts at the raw data and goes through all of the components that lead up to the prediction or the consumption of the outputs. And I think that this is going to increase you and your team's productivity by thinking about this as a system and wasting less time on hacky solutions that don't really fit what you're going to need in the end. And I think that the other thing is you need to understand that what your needs are if you're going to get a real chance at solving them properly. And this relates to a different talk that I've given in the past about solving MLOps from first principles. And so that's what we're trying to do with this specific problem today. So let's talk about first principles thinking. And this is Stable Diffusion's interpretation of someone thinking from first principles. But in order to take a first principles approach, we basically are going to discuss our assumptions about the problem and then break this problem into the smallest irrefutable pieces and build the solution from the bottom up with those pieces. So what are we assuming about this problem? First and foremost, I'm going to focus on what I think is the simplest case for deployment, a single model. I want to make it easy to understand the thought process behind deconstructing this, and it'll be easier to explain in a way that you can extrapolate to your own special cases. So I know I mentioned that the deployment process is actually more complex than this, but we're going to take a simple flow, and I think that it's going to apply to the more complex cases, but will be easier to learn. If you feel like you have a more complex use case and you want some help discussing how to deconstruct it according to the principles I'm going to show in a moment, you can reach out to me either on LinkedIn or in the Discord for PyData afterwards, and I'm happy to help. So what I'm just going to say is, if you remember the more complex pipeline that I showed earlier, imagine everything just fits within this model box, and that's what we're deploying. Last but not least, I am going to assume we are not discussing anything relating to the process of training the model. My assumption is that you have a model that's already trained, and you're just going ahead and working on the getting it to production. Great. So after all of that, how do we break the deployment process down into its constituent components from first principles? So we're going to now go over the theoretical breakdown, and then I'm going to go over each step and add recommendations and tips for how to get started with each step. So we have our model ready. And the first thing we're going to need to do is write a bit of code, some function that wraps the trained model, loads it, receives the data, and performs a prediction and returns that prediction as the function output, right? And this is pretty straightforward. Most of us do this almost as part of the process of training the model. And once you have this, it's great. You can now predict locally from your Python shell or Jupyter Notebook, and that's exciting. But that's obviously not what we're looking for right now. We don't only want to predict locally or just in the language in which we wrote the function for that matter. So we're going to need a universal language in which we can communicate with the model that we built, which is going to be the interface to the real world. And it's going to, so basically what we're going to do is we're going to wrap our model in some API that can receive a request, for an example, a JSON file sent over an HTTP request, parse that information, send it to our function, and return the prediction in some other standard format JSON. And once we've done this, we can basically now communicate with our model in a universal language, which is awesome, right? But it's still running locally, and that's not what we want. So we need to figure out a way for it to be run in other places. Or in other words, we want to make sure it doesn't just work on our machine. And this is Stable Diffusion's interpretation for the Johnny Depp on the bench meme, where they made both the people Johnny Depp. And the fact that I'm mentioning Docker here is me kind of breaking the rules of first principles thinking for the meme's sake. But generally speaking, the next step is to make sure our API is inside some environment that makes it portable and able to run wherever we need it to. We can call this step containerization if we want to adopt Docker's terminology, but it doesn't have to be Docker if that doesn't fit your needs. And the main point I'm trying to make here is we want a package that contains the environment, code, the API, and other requirements that we have so that we don't care which cloud provider or machine I'm putting this on, it can just run. And once we do that, we have basically a portable environment for our model, and it can communicate with the world in a standardized format. And the resulting communication triggers a function that returns our model's prediction. So we're almost there. But the last thing that we're missing in this sort of entire thing is that everything should exist someplace where our consumers or users can use it. In other words, we need some infrastructure to host our container. And this usually means the cloud, a magical place where anything could happen, but it of course doesn't have to be. Infrastructure could be on-prem or on an edge device as well. And once we get done with this last part, we basically can use our model from anywhere we want. We have a universal language that can trigger it, and it returns the predictions that it has. And so it's basically ready to be incorporated into our product, whatever that is. So to summarize and put everything in one slide, right? This is a simple 4-step breakdown of what deployment means, taking a first principles approach. And you might say at this point, well, this is simple, right? Like I sort of knew this. But the reason this is awesome in my mind is that it means we no longer need to solve the problem of production or deployment. We have 4 much smaller, much more tractable problems to solve. And once we solve all of them, we're basically in production. So now that we have all of this laid out, let's go over a few recommendations for each step, including the recommended tools. So step 1. And I think that for step 1, the default choice here is always the tools that you're already familiar with when it's possible. So for most of you, this probably means Python and some TensorFlow, PyTorch, Scikit, whatever it is, right? And this is just assuming that there are no constraints on the language you need or the frameworks that you need. It might be that you have to do this in Go or C++ for efficiency's sake, or for connecting with other data processing steps, which might or might not have sort of dedicated bindings for the frameworks that you trained the model in. The other thing that I think is important to note is the way you save your model can affect its future portability. If that's something that you care about, you might want to look at portability first formats like ONNX. This might be especially important if you deploy to multiple types of endpoints. And more generally, as your company grows, you're going to want to converge on sort of a single or maybe a few processes for deploying your models. And this means somewhere in your pipeline, you're going to want to standardize everything. So exporting to some standard non-framework specific format is a great way to future-proof your project in that respect. Last but not least, if you expect to have additional models deployed in the future, it's worth spending a bit of time defining which functions need to be implemented and defining a company or team-wide class or interface. This is going to improve interoperability in the future and enable you to build infrastructure and automation down the line that will support and be relevant to future models. Many tools that automate the deployment process require you to comply with such a format anyway. So it's a good idea to adopt this mindset early on. And this doesn't usually cost you too much upfront, but it can provide a lot of value later on. Okay, so now we're at 2. The recommended tools for this task can be anything from manual implementation with Python requests all the way to Fast API, which is currently my personal favorite. Now, all of these are great tools, and if you want to learn how to use one of them, you can basically Google tutorial machine learning API with X, and you'll find great materials. It is important to note that some model consumers require non-flexible endpoints. So to give a concrete example, there is a labeling tool that supports machine learning model auto-labeling with an externally deployed model. Now, this tool requires that the endpoint be at sort of some HTTP model URL / predict, and it won't accept anything else. So if you have predictions, for example, that doesn't work for that tool. Now, if you're using that tool, you're going to need to make sure that you implement the predictions the proper way. And this can be expanded to the fact that you might need multiple endpoints for the same functionality if your data consumers require that, even though, of course, it's ideal to create a standard here as well. And I think this requires sort of a small note about authentication. At this point, you need to also consider what the context for your deployment is going to be. If you have a distributed microservice architecture and your model is going to be exposed to the web, you're going to need to spend time implementing proper authentication for it. Now, this is beyond the scope of this talk, but from my experience, this is a glossed over detail that sometimes surprises people when they're implementing their path to production. Some infrastructure providers have out-of-the-box support for authentication, but you can also implement, if you need custom deployments, you can also implement this yourself. And again, here, if you Google authentication with tool X or authentication with, for example, Fast API, it's going to provide some example tutorials for this. And I'm going to provide one specific one that I recommend later on in this talk. Okay, so now we're at step 3. So in this case, my answer to recommended tools is, of course, Docker. A lot has been said and said about it, but in the end, it's a good idea to have an understanding of how it works and how to use it. It's very customizable, and even if you use something else, it's probably using Docker under the hood, so a basic understanding is warranted. There are a lot of tools that are offering a simplified and automated process that covers sometimes a combo of step 2 and 3 together. So they write the API wrapper and containerize the model in one go. And they are awesome. But it is important to know that there is a built-in trade-off. So the reason they're able to make an easier path to manually doing 2 and 3 is that they make decisions on your behalf. So if you have a very standard deployment process, they are very likely a good fit. But know that for customization, you're probably going to dive one layer deeper and get into the nitty-gritty of what is usually Docker. So this isn't a full replacement, and I still recommend having a basic understanding of Docker nonetheless. Okay, we're almost at the end. So for infrastructure, in our final stage, I would argue that we don't really have recommended tools as much as our necessary deployment setup. And this stage probably has constraints like whether or not we're deploying a microservice endpoint, Lambda function, or pipeline stage, or on a user's edge device. So depending on what you need specifically, you're going to need to adjust sort of the implementation of this last phase. An important caveat that at least I failed a bunch of times and sort of caused me a bunch of misery, so hopefully I'll help you avoid, is that in all stages as well, so this applies to step 3 and step 2 as well, you need to remember that the incoming and outgoing traffic that is going to your model is going to pass through all these additional layers to get to the actual model function that's doing the prediction. So it's really important to open the ports or open the paths from the infrastructure through the container and to the API. And this might seem obvious, but again, it has caused me unnecessary grief. So hopefully I can help you avoid that. And of course, a talk like this wouldn't be complete if we weren't talking about GPUs. Most of the existing infrastructure that is built today isn't really targeted towards machine learning. The first and foremost priority is just software workloads. And one of the main things that we need that is dissimilar from software workloads is a significantly higher demand for GPUs. Now, working with them is sort of notoriously more complicated. You need to pay attention to things like CUDA, and many of the tools that I mentioned in the previous stage sometimes help you that sometimes help you automate step 2 and 3, also assist in the configuration of GPUs within your environment. But you can also find great content about working with them directly or via dedicated cloud services like SageMaker. I'm going to provide a piece of content for this in a moment. So this is basically it. We've reached the end of our journey and we're in production. And I want to end with a few resources that will help you take the next step with each part of the process. So this QR code is for a Google Doc that basically includes all of the steps. And I'm going to share the link to this doc in a moment in the chat. But we have here something for how to build the API for the machine learning model, how to add authentication, how to use Docker in data science context, and then how to deploy GPU accelerated applications with AWS and Docker. So with that, thank you very much for joining my talk. I hope it was useful. I'm happy to take questions, and you can follow me on Twitter or LinkedIn if you like content like this. And feel free to reach out to me, again, if you think that your process is a bit different and you want advice on how this sort of breakdown process works in your case. So I'll stop sharing.
Thank you. Thank you. We do have one question, and that is, why do we need authentication when model is exposed to the web? I'm sure there is an obvious reason. I'm just not aware.
Yeah, so the first time I stumbled on this is one of the teams that we were working with basically deployed a machine learning model, and the model was deployed through one system, but the consumers of the model existed in another system. So they had basically they had multiple ways to solve this, right? But the way that they decided to solve it is basically to deploy the model on AWS and open it up to the web and have the consumers from the different systems access that API endpoint. The problem is it had proprietary information, so you don't want to give access to the entire internet to your model endpoint. And so in that case, what they basically needed to do is they needed to add authentication to this entire process so that they can know that the people that are querying the model should actually have access to it and should receive the responses. So that's sort of the main example I can give.
Thanks. Perfect. Yeah, we have a lot of comments saying thank you. It was awesome, very insightful. So thank you so much, Dean.
Sure, happy to help. And yeah, as I said, I'll be on the Discord for a while now. If you want to reach out to me via DM or something like that to talk about more complex or specific cases for deployment. And if you have some more questions, I'm happy to answer.
Oh yeah, we got one more just now. I'll show it. What do you think about project organization, a particular file structure to recommend?
Sure. Yeah, this is a good question, which I actually I'm working on something on this front as well, which I'm hoping will be released pretty soon. Basically, I think that the main thing to remember, if I'm being objective here, is that the important part is to converge on something and then have it across the organization, and that adds sort of a lot of value in sort of being able to move between projects in your organization and understand what's going on there, because you don't have to relearn the process from scratch. And the specific recommendation I have here is, of course, like cookie cutter data science, I think provides a really good starting point. And I'm working right now on a project that's sort of I'm calling it like cookie cutter MLOps. And the idea is to add a bit of things that are more related to production in the context of machine learning into this template. So So that's sort of the way I'm thinking about this. But again, the important takeaway here is decide on a structure that you think is right. You can use cookie cutter data science, it's great. And then make sure that every project starts from that structure. And that's the best way to set yourself up for success down the line.